if you just put this bowl upside down and somehow we manage to keep the ball at the top. Now any nudge to that ball is going to result in that ball falling to the bottom. This kind of situation is unstable equilibrium. Now unstable equilibrium, in the graph if you see this of u versus x, unstable equilibrium meaning the point would be at this position of the equilibrium of the potential energy, because if we consider any point ahead of that maxima at in the potential versus displacement graph, now all these points which are towards the right, the tangent to this is making an obtuse angle. The slope of the tangent is negative. dy by dx is negative. That means the force is positive. So force is positive. So force would be acting in this direction, the same direction in which the displacement has occurred. Now that force is going to drag that ball further towards in the same direction in which it had initial displacement. It is not going to bring it back towards equilibrium because force is in the direction of displacement. Similarly, at a point towards the left of the peak point on this graph, the slope is positive. That means dy by dx is positive. That means force is negative. Force is negative meaning the force is directed in this direction, and the displacement from this point to this point is also in this direction. So the force is going to further drag the ball in the same direction. It is not going to bring it back to the equilibrium. So via this graph we understand that this point should be the point of unstable equilibrium. So if we are going to encapsulate this condition into equation, we are looking for actually condition that the point should lie at a point at which the potential energy is maximum. This is the condition actually, and mathematically we can say that of course at this point as well the slope of the curve du by dx should be 0 and du second derivative of the potential should be less than 0, because the first derivative, the slope is positive, then 0, then negative. So the first derivative is decreasing, so that derivative of the first derivative should be negative, because if a function is decreasing then derivative of that function should be negative. We had this discussion before. So derivative of first derivative, that means the second derivative should be negative. So these two conditions would mean that the point is actually at the point of unstable equilibrium. Okay, so this completes the theory. Now we are going to look for problems. Now to solve a quick one here itself, let me give you a function and you tell me, you find all the points of stable and unstable equilibrium. Suppose the function is x cubed by 3 minus x squared by 2. If this is the function, find all the points of stable and unstable equilibrium. Please do it. The first thing, whether stable or unstable equilibrium, this will hold true. So let's find the points which satisfy this condition. Du by dx is 0. Du by dx is equal to x squared minus x. Now for this to be 0, either x is 0 or x is equal to 1. These 2 points will satisfy the condition. Now second derivative, d square u by dx squared is 2x minus 1. Now for x is equal to 0, the second derivative is negative. That means this x is equal to 0 is a point of unstable equilibrium. For x is equal to 1, the second derivative is positive. That means x is equal to 1 is a point of stable equilibrium. Okay, that's how you do it. Easy? Okay.